boring. All right, good. Please feel free to ask any questions throughout. This is sort of open-ended. I can talk about this for 2 hours, but I can also keep it shorter. So I guess I have about 50 minutes. But please ask questions. So, and this talk grew out of sort of myself realizing after a long and often frustrating period of what it actually takes to write papers. And a lot of that I learned not only from my own rejections, but actually from sitting in program committees and really understanding how papers are evaluated. And so I'm trying to get a little bit of that experience to you people. Because basically, I wish someone would have told me this 15 years ago. I would have been more successful. So first is really an understanding of what is systems, right? Systems is about building stuff. So you can very oversimplify the computer science as being theory and systems. That it is definitely an oversimplification. But if you do that, then theorists build theories and models, and they can get away with doing stuff that's not obviously good for anything. And I really apologize about the green font it shows. This is our standard corporate style, and it's really not bad, not good if the contrast of the projector is not great. And on the other hand, systems people actually build stuff, and they build stuff that has to be good for something. You can't get away in systems by doing something that looks interesting, but you can't convince people that it's not good for something. So this is a really important thing to understand. And so systems is sort of broad. There's operating systems, network systems, distributed systems, database systems, programming systems, even machine learning systems. They all have some flavors of systems work. I understand most about operating systems and what's considered the narrow, in a narrow sense, the systems community, which is really operating systems, network systems, and distributed systems. So this is where my experience comes from. I know that some of this will translate into, say, database systems or programming systems, but I'm not making any guarantees, right? So first, a few disclaimers. I don't claim any expertise in making exciting talks, and in particular exciting talk slides, so don't take these as particularly good examples. And then, even though I've been around for a while, I don't know everything myself, and I'm still learning. And in particular, I get papers rejected just as you do, and so does anyone else, by the way. So just to give you some examples, these are my statistics from 2013, that was my best year publication-wise since 2009, the famous year with the best paper board at SOSP. So not bad, right? I got 11 papers accepted in top conference, USSC, SOSP, APSys, a few good workshops, 1 journal papers. But in the same year, I got a fair number of rejects. So I got 2 papers rejected at Usenix, 1 at PLDI, 2 at RTSS, 1 at APSys, even at APSys, right? 1 at MSOF, and 1 at APSys. So I said this is a good year, yet I had about a 40% rejection rate. So keep that in mind. And so you might ask, if someone can't even get a paper into APSys, what are they trying to tell us about getting papers published? But yeah, I'll get to that. And there's also other resources which address similar issues and give some hints. Okay, so here are my rules of writing. And this is basically probably the most important takeaways from this talk. First is that reviewers are potluck. And that is even at top conferences. So it's a fact of life that even top papers get rejected sometimes, and sometimes for good and sometimes for bad reasons. So even everyone who is a successful systems researcher will tell you stories about some good papers they had rejected. And in some cases, it was because they just happened to have bad luck with reviewers and got the wrong reviewers who didn't really get it. But in almost every case, you have to look for the fault on your own side, because in the end, you didn't do a good job at selling it to the reviewers. So rejection is part of life. You have to get used to it. If you get frustrated by the rejections, then you shouldn't try to do systems work, because you can't live there without having papers rejected. Even like the top field, people in the field, the Turing Award winners, they all had papers rejected. And yeah, it's sometimes the reviewers are blatantly wrong. If you look at my blog, I put up the rejection, the reviews from my last year's rejection, and comments and showing that the one negative reviewers actually had everything factually wrong, because the paper said the opposite of what they claimed. These things happen, and you just have to move on. But the point is, you can minimize the chances of this happening by taking a more systematic approach. And you need to understand why papers get rejected. So these are the top reasons reviewers reject papers. Remember, systems is about solving real problems. And you can get rejected because you don't convince people that you're tackling a real problem. You can get almost any crap into second or third tier conferences, but not the ones that count, the ones where a paper has impact. They will not let anything in where you don't convince them that you're dealing with a real problem. So not convinced you're solving a real problem, or maybe it's a real problem, but the reviewer is not convinced that you have actually solved it. You may just come up with something that looks nice, but if you scratch at the surface, it's not actually a solution, and it doesn't really work in reality. So these are the important things you need to get across, that the problem is real and your solution is real. Or maybe they just don't understand it. If I don't understand a paper, I'm not going to let it in. I'll get it. I'll work on rejecting it. Unless okay, it may be that I don't understand it because I just don't have the expertise, in which case I trust the others. But if it's something which is in my expertise and I don't understand it, then as far as I'm concerned, the paper is not ready for acceptance. And then there's cases where the work is okay, but the venue is highly competitive and there's better papers. And it just doesn't get in because it doesn't excite people enough. And that's the difficult cases, right? In general, you're better off having a paper that is a bit more controversial than something where, okay, there's nothing specifically wrong, but it doesn't excite me. Then you may not get strong enough reviews to get it. So one of the realities of life is, in a PC situation, it's important to have a champion. So the papers that are sort of, okay, sort of nice work, not overly exciting, they get sort of a few borderline accepts, and in the end, that's not good enough. A paper that people have different opinions, someone really likes it, and some thinks this is crap, in the end has a better chance, because then it gets argued about at the PC meeting, and people put their arguments on the table, and usually the better arguments win, not always, but usually the better arguments win. So I had papers, I had a case where I was the only accepting reviewer on the paper. That was last year's OSDI. 5 reviews, I think, 5 or 6. I had a strong accept, and all the others were weak rejects or clear rejects. And the paper was discussed 3 times. In the end, I won. I got the paper because I thought it was really great stuff. I championed the paper because I thought this is actually very, very cool. And they solved it badly, but that can be fixed in shepherding and everything. It's probably an unusual situation, because in this case, typically the majority tends to win, but people are open to arguments. And if you get at least one person excited about the paper, you have a really good chance getting in, even if there are faults with the paper. People will be willing to take a bet that the faults can be fixed in the shepherding process, as long as the paper itself, the work inherently is good. So it's very difficult to sort of do this deliberately, right? But the best you can do is try to get some excitement factor in. Why would someone find this cool? If you can get someone really to think this is cool stuff, then that's a good way to get the paper accepted. And of course, that implies that if the work is very incremental, has very little chance of getting it. Okay, so my second rule is a paper, and this is basically a follow-on from the first rule. A paper has to have a clear story, and the story is what sells the paper to the reviewers. So there needs to be a well-identified message. If you write a paper and you can't explain to me the main message of the paper in 2 or 3 sentences, then the paper is not ready for a top-tier conference. You really need to be able to succinctly say, what does this work do? And that message needs to be brought across very clearly in the paper itself. So you first off need to understand yourself what the message is. You need to clearly decide what is the one paragraph pitch for this paper that sells it. And then you need to build the paper around that. So, and make sure that the reader actually gets this message. And of course, it only helps if it's interesting. And so the whole paper needs to be built around that message. So everything really from the beginning, from the first line, and I'll go into a bit more detail later. And another sort of important thing to remember is people have lossy memories. You need to understand that someone who reads a paper will not remember all the details. Particularly since in reality, if a reviewer reads a paper, they don't always have the chance to read the paper front to end in one go. If you're in the program committee of a major conference, you have a stack of 20 papers of about 10, 15 pages length. Each takes, depending how much routine you have, between 2 and 4 hours to read carefully. That's an incredible amount of work. And of course, you've got 6 or 8 weeks to do it, and it's almost a full-time job during that period. So you sit there, you start reading in the morning, and then you get interrupted by this, and you have to go to lunch and whatever. So some papers you read end to end, and many others you don't. And that means when you go back to the paper, you need to have enough context left to really keep on understanding it. And it's important to understand that when you write the paper. Sort of don't expect the reader to remember every detail you said on page 2 by the time they reach page 10. You need to refresh their memory. First, think of it being DRAM, right? It's lossy, it needs to be refreshed.
So I just want to add, I mean, one thing I strongly agree with everything you said. I want to qualify one thing. One thing I personally don't like is when papers are very repetitive.
Yeah. You don't overdo it.
Yeah, I mean, we need to think like, oh, repeat.
Yeah, I didn't say repeat, right? It's a gentle refresh.
But that's our repetitive. That's not good. Yeah.
Examples are sort of definitions, right? You introduce them early on, and then you talk about background and other stuff, etc. And then you sort of gently need to refresh. Same with acronyms. If you have non-standard acronyms, you define them at some stage, and then maybe you don't use them for a few pages, and people will have forgotten. There's a nice way to gently remind people what they are. Say, if you say, for example, IoT, right? Internet of Things. Right, it's IoT. And then not use it for a while, and then it's sort of a nice way to refresh it. The first time you use the term again, just use the full extension without without redoing it.
Redundant system. Yeah.
So you use the full expansion without repeating the definition bit, but then when you use it again, just use the acronym. And that gives enough context to refresh people's memory. It's very difficult to, some people have a good way of putting themselves in the reader's shoes and keeping track on how much context the reader has. And this is a very important skill which you can develop over time. So it's putting yourself in the reader's mind is really a key. So what does the reader know? What might they have forgotten by now, etc. If you master that one, then you're a good paper writer.
Question?
Yes?
How do you have the suggestion on putting some forward reference, backward reference?
It's good to minimize both of them, I think. So sometimes you generally learn to avoid forward references. Sometimes they're sort of necessary, right? For example, you just glimpse at something, but you don't really want to go into detail in the introduction. I'll talk about later how important the introduction is, that you don't waste space on it. This is sometimes a good way to have a forward reference, where you just sort of give a vague idea and then say, this is more clearly defined in section blah, blah. These kind of things are a good justification for forward reference. In general, you should minimize them. Backward references, sometimes it's sort of the refresher thing, right? If you haven't talked for something for a while and you start talking about it, and you might have the back reference to where it's defined or introduced, and that might be helpful for the person who's forgotten it to quickly find it again. And then the two really important rules about how to write a paper is what I call the 2Cs. So those who do know about caches, there's the 4 Cs about caches, what makes cache, produces cache misses. For me, in writing, there's only 2 Cs. It's clarity and conciseness. So both are really important. Clarity means that for every sentence, every paragraph you write, you need to know what the purpose is. Don't just dump stuff there. Everything needs to be really deliberate. When I write on a paper, for every paragraph, I very clearly know what I want to express there and how this paragraph contributes to taking the reader forward in their journey through the paper. And of course, that only helps if the reader actually gets that message, right? It needs to be clearly communicated. And it needs to be consistent with the rest. So the whole thing really sort of builds step by step. It's like building a program, right? You build it up step by step. And the other is conciseness. So you need to be concise. Waffly papers generally don't get very far. Sort of the repetitiveness is an aspect of the waffliness. So and this is what I find with students very often. When students start writing, they tend to be very verbose. And my typical rule of thumb is, even if a recently well-writing student gives me a draft, I can apply what I call lossless compression, or gainful compression, and I reduce the draft by about 1/4 in word size and improve the clarity in the process. And this is something that's definitely an acquired skill. I don't think many people are born with that. It just comes from practice. And it again has a lot to do with putting yourself in the reader's mind and trying to experience, trying to sort of think of the experience the reader has by reading this paper. My first PhD supervisor. Okay. So my first PhD advisor, I had 3 of them. I was very careless in my youth and lost the first 2. My first PhD advisor's name was Jay, and he had this rule of thumb on writing a paper, he would hold his thumb over random pieces, and if he thought it still made sense, then he crossed it out. It's a very good rule of thumb. So, and with clarity comes precision, or the other way around. Precision sort of requires clarity, right? A very precise data, which we should be used to as software people, used to writing program where you really need to be very precise. The same is really appropriate for papers. Be very precise and clear with what you do. And really, and this is a very hard skill to learn, is making the reading enjoyable, have a lucid writing style. Very difficult, and typically it's not the engineer kind of folks we are that have this. But it's something, if you master that, then you can write great papers. And the really good people in the field, a lot of them are able to write these really nicely presented lucid papers. But that's the flip side of that. Be as concise as necessary, but not more. In particular, remember the lossy reader state. Do the gentle refresh every now and then. So, in particular, very important, of course, define before you use it. Amazing how many people sort of start off with some using some term and then defining the page later. That's very bad. Always try to remember the reader's context, what they learned and what they haven't learned yet, and then just do the gentle refresh. And then the number 4, which is a sort of really a follow-up from number 2, is that presentation methods. This is what I call paper engineering. So I consider myself, I mentioned yesterday, I don't think computer science is mostly a science, with some respectable colleagues like Robert here as a notable exception. But I'm definitely an engineer, right? And I take an engineering approach to whatever I do, including paper writing. And I think paper writing is really a form of engineering. It's, I already said that, right? Reviewers are busy, and if you are with even this stack of 20 papers, and you know in round 2 you have another 10 to read, and you're really, as a reviewer, you're really looking for reasons to reject. It's unfortunate because it means that reviewers generally tend to have a relatively negative attitude when reviewing papers, but it's just a fact of life. We are hit with so many of them, and it takes so much time to go through them. You're really looking for reason to knock papers out to make progress in the process. So be careful not to give easy reviews for rejections. And that's clarity is one of them. So these are the important bits of the paper, as far as I'm concerned. Introduction is incredibly important. One of the bad things I learned from my third advisor was that the introduction is unimportant, and you just tag it on at the end. I totally disagree. So my approach is, when I write the paper, I first, or a student writes the paper if they're good enough, advanced enough to do that. I generally write the introduction myself, even if it's mostly a student paper. But the very senior students, they can do the whole thing. But typically I start writing the introduction. That defines the roadmap for the paper. And then let the student do the work, and then come back. Then I do my gainful compression of the paper. And then we do the experiments and do the evaluation. And of course, you can't really finish even the introduction unless you have the complete results, because you really need to know what you can sell at the end. So inevitably, you have to go back and redo the introduction. But it's really important to have it there first as defining the message of the paper, which everything else has to align to. But it's also equally important to go back at the end to redo it and make sure it is consistent with what you actually achieved in the paper in the end. Build tension. I remember, yeah.
Along with the UA technical, you like how much that?
Depends how good the student is at writing to start with. I'd say probably takes me similar time as when I review a paper. 3 hours, rough, plus minus to go through it, and then sort of I go and edit the stuff in, or depends, sometimes I just leave it to the student because it's part of their learning, right? But it takes a considerable time to read it carefully. But sometimes you sort of I end up rewriting whole sections completely, and that's mostly the case for junior students. And yeah, it's part of the learning process. It's still good the student had a go, right? That's how they learn it, and they then see what they do.
The way I usually go about it with my students is that I write them. Students work and we'll sit together, but I do most of the writing. The second time, the student does the writing, but I'm heavily involved. And then hopefully the third time, they sort of get the picture. But it depends a lot.
So of the students I graduated, I would say half of them would, in the end, write the paper 95% on their own, and I just do fine tuning. The other half, I still have major involvement, even at the last page. I don't remember the paper, what it was, unfortunately, but I do remember reviewing a paper once, which read like an Agatha Christie crime novel. You sort of, it kept this tension up, right? And that's actually, you're trading a fine line there, because one of the things I'm going to talk about in introduction is it should be like the overture of an opera, in sort of making the main points. That paper managed to do that without giving too much away and keeping me really glued to my seat. And are they really going to pull this off? I can't quite see it, but it's not quite impossible. And then to manage to build this, and I was really looking forward to reading the next page and learning the next step. It was amazing, and I'm so pissed off that I don't remember which paper it was. I should really list this as one of the really great papers. That's an incredible skill to have. I don't claim I have anywhere near this kind of crime novels skills, but it's important to keep the reader interested, right? Make sure that there's progress in what they learn all the time in an interesting way, and sort of build up the technical depth as you go. Obviously, convincing argumentation, right? Don't hand wave. You need to be really convincing with anything you try to sell. Very important. Good papers written top down, not bottom up. I had a postdoc a few years ago. He was from Korea, extremely smart guy, technically very good, and he wrote this paper, and I read it, and it took me a long time to understand what it was, and really it was this bottom-up approach, right? He started with the details and then built up the high level, and this is the wrong way to do it. So I ended up rewriting the whole thing in a top-down way, and it got into Sigma, it got the TOTS invitation and stuff, so that the paper was quite successful in the end. But initially, it was extremely hard work to try to get out what the paper was really trying to say. And this is this bottom-up versus top-down, right? As microkernel people, we tend to be very bottom-upish in the way we work, right? But that's not the way you sell a paper. The paper is done top-down. Maintain reader state and convincing evaluation. I'll talk about that second. Yes, very important. Be very honest and upright about any assumptions and limitations. One of the really good things to piss reviewers off is if they have to second guess your assumptions. And if I try to, it basically means if the assumptions in the paper are not clear, then I'm immediately suspicious, and I'm trying to find out where you make some really dodgy assumptions. And I have a very suspicious attitude to every bit of the paper until you hopefully convince me that your assumptions are sound. Don't get there. State them up front. If you think your assumptions are too strong and the paper is therefore not convincing, go back and redo the paper, submit it later on. It's a waste of time. You need to be really clear with your assumption. You need to be honest about it. Worse than not being clear is being dishonest. And I see that as well when papers people claim these are the assumptions, but then you really find that there's actually much stronger assumptions hidden below. That's pretty much a dead sentence when I find that. The paper will be rejected. And Same with limitations. Be upfront. Every work has limitations. It's not shameful to have limitations in your work. No one solves all the world's problems at once. There's always limitations. It's much better to be upfront and tell the reader early at the appropriate time what the limitations of your work are, rather than guess or then coming with it later on. And of course, that's often something that happens on the way, right? You think you have a really good solution, and then you work on the evaluation, and as usual, the results come in very late, and they're not as convincing as you hoped. And basically, what it translates to is the paper is more limited than you hoped. And maybe it's still good enough to get in, but you need to go back and rewrite the introductory bits, the first couple sections, to make clear that the limitations are actually upfront. Same about, of course, what you claim, what you deliver. So, because I said I think a paper's engineered, structure and style is really important. So, like any opera, a paper has an overture, and that's what we generally call the introduction. So this is which introduces the problem you're solving. You explain why it's a problem, and you give a rough idea on how you solve it and what you're going to achieve. These are the main things, right? At the end of the introduction, I expect to have a clear idea of what I will be getting and a rough idea of how it will happen. So you need to outline your approach. Don't try to hide it. And this is where I said it's sort of walking a tight line between the Agatha Christie kind of approach, right? The real crime novel, of course, doesn't give anything away. Then you find out who the murderer is on the last page. That's not what you want. Give away enough, certainly, that I, as the reader, find it credible. But this is the important bit, right? The reader needs to find credible what you do. Otherwise, they get into this highly skepticism mode, which is makes your life very difficult.
Are you going to talk about the abstract later? Or?
Yes, I will. So, important that the reader gets away at the end of the introduction, knows what is the problem you're solving, has a rough idea how you go about solving it, has a rough idea what you will achieve. Actually, better than a rough idea, you should actually explicitly state your contributions. This is a very good practice. At the end of the introduction, we make the following contributions: 1, 2, 3, 4. Very clear, very explicit. And that then defines the benchmark against you want to be measured, right? This is actually the good. The bad thing is you can't hide anything, but you shouldn't try to hide something in the paper. If you try to hide something, the paper is not good. The good thing is you define your own ground on which you will be playing. If the reader thinks the contributions are not significant enough, then that's tough luck. There's no way you can overcome that one. Much better off being clear up front. But once you define your contribution and the reader finds it credible, then you define the turf on which you're competing, and you sort of you play to your own rules rather than someone else's. Very important. The intro is the first step to make me interested in the paper, so you want to capture my interest. It's also important to be concise. A very good rule is the introduction should not be longer than a page. I try to, it's definitely not longer than that. I try to get to the contributions by the end of page 1. But of course, page 1 is not a full page, there's time and abstract, etc. So it's fair enough to spill over. But definitely not more than the first column of the second page. If your intro is longer than that, then you need to go back and make it more concise. You're waffling or just throwing in irrelevant stuff that can be cut out. And very important, right? You clearly define in the intro what you're going to deliver, and then later on you then make them sure that you actually deliver that. There's one thing every reviewer really hates, that's called bait and switch. If you bait them with some real nice things in the introduction and then don't deliver on them, that's a very good way to kill a paper. very few people will accept that.
As a reviewer, I always go back and make sure that that every contribution that's listed in the introduction is in fact discharged.
Yes, it's like a proof obligation, right? Need to be discharged. I won't go into as much detail in any other section except the evaluation, which tells you how important the introduction is, right? It's the thing that's really worth spending time on. And typically, sometimes I agonize on the introduction for 2 days, and I'm as good as procrastinating as any PhD student, by the way. And starting a white sheet of paper for a new paper is a good way to get into procrastination mode. Yeah. But it's sort of pointless to continue until you've done a reasonable job on that. So then after that, there's typically, this is not a strict rule, right? A lot of papers are written like that, not all of them. If you have a good reason, deviate from this by all means. But it's generally a good pattern. You do the background. So the introduction, you introduce the problem and how you go about it at a high level, enough to capture the reader's interest, but not going into much detail because you want to do it within one page. Then the background. This is where you sort of start explaining more about what is the background of the problem and other solutions, etc., etc. And then you go into more detail and you this problem description. This may not be separate sections, but typically that's sort of the sequence. And then obviously you present your solution and describe it in detail. And then in a system paper, evaluation is typically the biggest part. That's often 4 or 5 pages. And then related work, some people do it as a second section. It's actually, and I used to do that often myself, and then I read this thing by Microsoft guy, Cambridge PL guy, Sam and Jones, yes. And he convincingly argues that related work should be at the end because it's where you have other truth you have to cover, but you're not really that interested in, so leave it till late without sort of distracting the energy of your reader. In the background, you will introduce a lot of related work. That's really important for understanding the whole context of the paper. So there will be a lot of sides to other people's work in the background section, but then you shouldn't try to cover all the related work. Do a short related work section at the end where all the other sides you have to put in and where you have to quickly contrast with stuff which people will have heard of, which may sound superficially similar, is actually quite different. It's often just enough to use 1 or 2 sentences to distinguish yourself from that. So related work, if you've done a good job on the background, the related work can be quite short. It's typically less than a column. And then conclusions. And then the abstract, which is at the end, because I typically write it at the end, because you really need to understand what the paper will be able to use to write the abstract. And a paper really has 2 abstracts. It's the abstract it gets submitted with, and it's the abstract that accepted paper has in the proceedings. They're different because they serve 2 completely different purposes. And a lot of people don't understand that. The purpose of the abstract of a submitted paper is singularly to steer it to the right reviewers. You want to get the right people, the ones with the right competencies interested in your paper, and tell everyone else not to read it. And that's important, right? It's annoying for the reviewer if you get stuck with a paper which sounded interesting, but then you find out, no, this is not my space at all. But by that time, the decision has to be made, and you have to review a paper which you hate reviewing because the area doesn't interest you, you don't really know much about, and implied, of course, is your reviews are unlikely to be very competent. So that helps no one. The reviewer hates it, and you get an incompetent review. It's not a good idea, right? It's really important to put in the right sort of keywords in the abstract to get the right reviewers interested. You're always better off, unless you have something to hide, in which case you shouldn't even bother submitting, you're always best off having the most competent reviewers on your paper. And the abstract helps them. The title as well, by the way. I used to underestimate the title, the importance of the title, but the fact is, These days, conferences get 300 submissions or something. And from these, you have to pick your review preferences. And you don't even have time to read all the abstracts. So no decisions you make just based on the title, and then if it sounds interesting, you then read the abstract. So it's already important to pack enough information in the title about what this paper is about. If you like a catchy title, you can still do that later. At the submission phase, it's more important to have an informative title than a catchy one. So it's what, why, achievements, blah blah, but it's really just to have the right keywords in there for getting the right reviews. Jeez,
Say a little bit more about abstract. Computer scientists, of all people, should know what an abstract is. Abstract is the abstract that goes in the final paper, or in fact, the paper after the abstract, that one should be a summary of the entire paper. That's what it is. The summary. It's not an introduction. It doesn't fulfill the same goal.
In particular, it shouldn't be too long. I often get abstracts that are like almost half a page. It's a bad idea. Yes, 1 or 2 paragraphs, short paragraphs. Yeah. In most cases, yes, and that's why I'm not spending any time. So. Evaluation is really important, and it's in systems papers, right? And it talks about, even though I had this SOSP paper with no evaluation, but I was the one that broke all rules, and I knew that. But in the end, you build a system, right? You need to show that it actually works, it delivers on its promise. And you need to really show 2 things in the evaluation. You somehow change something in the design or the implementation, and you need to show that it is beneficial, but also that it has no unacceptable negative effects. So this is why the evaluation needs to demonstrate what I call the progressive and the conservative criteria. The progressive criterion is to show that you make actual progress. So you solved the problem, you improved something significantly enough for people to care. The conservative is you didn't undermine what was already there, so you don't make things worse in ways that people care about. Sometimes there's clear trade-offs, and then you need to discuss, right? And you may say, well, this solution is particularly of relevance for this kind of scenario and not for others. Or you can argue, well, there's a performance degradation, but it's so minute, and it's clearly balanced by the other gains we make. But as a reader, this is something I'm always very suspicious about. If people just show good numbers and don't convince me that overall they haven't lost somewhere else. That's very important. If I'm not convinced of that, then your paper will have a very hard stand, and I don't like your chances of getting in. Right? You need to convince the reader that you haven't done damage by doing the improvements in it. Some hates. I already said avoiding bottom up. Spell check and stuff like that. Avoid buzzwords. Novel is the one that I don't particularly like. In areas where they have professional copy editors, they tend to remove the word novel from title, abstract, introduction completely. And I think that's good. This very rarely adds something. Of course, it's what you do is novel in a sense. Otherwise, you wouldn't bother writing about it. There's words.
That's true.
Tagging keywords together. And really important, as part of writing a paper that's interesting to read, avoid passive voice. Use active voice as much as possible. Passive voice makes for very boring read. And I see that from a lot of our students. For some reason, it's particularly electrical engineering students who write everything in passive voice. I'm not sure whether they taught that in the labs or something. It's really bad. Avoid it. And for 2 reasons. A, it really makes a boring read, but also it sort of dilutes responsibility. I don't know whether when you say, blah blah has been implemented. Did you implement it, or did you take someone else's implementation, right? Take responsibility, and active voice is a good way of doing that. I said that already. Maintain reader space as reader state, because their brain is lossy, and you need to refresh a bit. And yeah, don't play with formatting. He will really get pissed off if you play with baseline skips and stuff like that. Spell check. It's very insulting for a reviewer to get a paper that is full of typos. And if you're not a native English speaker, try to find one to read your paper, to check for grammar, etc. It's a paper that breaks grammatical or style rules a lot is a difficult read, and if the more work it is for the reviewer, the more likely they like it, and less likely they like it. Some mechanics that are important: use revision control. Even if you write a paper on your own, but in systems that rarely happens, we tend to collaborate on papers, and it's important to use revision control. And by implication, don't use Microsoft Word. I actually know one person at Microsoft Research who uses Word to write their papers. Everyone else uses LaTeX as they should. It's just not a good idea, right? Citations are painful, but more importantly, it's a big kernel lock, right, for a macro kernel, where it doesn't make sense, because you can't read. Git or Mercurial are very good in doing automated merges. So we typically have sometimes 5 people working on a paper concurrently, and only when we do major revision, someone locks a section, and otherwise we just write and merge it, and most time the merge happens automatically, so you don't have to worry about the revision control. And of course, that's a way to maximize parallelism, right? Don't single thread unnecessarily. And yeah, use it. So I don't really have much time to go into the talk about the evaluation, so I'll just pick up a few points there. But there's a few other information sources. One is a real classic that's now 30 years old. The program committee chairs of the then SOSP conference wrote about what makes good and bad papers. This is very well aged. Simon Fenton Jones, who I mentioned before, he had great talks and write-ups about writing papers. He's a PL person, so not everything he writes applies directly to us. And I also have particularly aimed at students a guide on what to do in writing, what to look out for, etc. Any questions?
I think the audience here is mostly Asian, and there are language idiosyncrasies.
Yes.
So I think there's something probably I can share with Japanese students, and I don't know what Heiser does with his Chinese students writing.
Well, Heiser writes excellent papers.
like for example, like Korean students, they put everything at the end. I think it's our language that the subject and verb, subject at the beginning, verb at the end, everything in the middle. So the conclusion is always at the end of a sentence. So whenever I tell the students, don't write a mystery novel, just state up front what you want to say, but they say they did, but it's always at the end of the paragraph, at the end of the sentence. I have to prove everything. But then in Japan, right?
It's the same in America too. We write like that too. Nobody writes top down except for science people. Find one novel. Right, find one novelist that writes Nobody writes like that.
Look, I mean, it's quite clear that people who are native speakers of Asian languages have a harder job writing well. But it's not just you guys, right? I mean, my mother tongue isn't English either, and Germans tend to have quite a different approach to writing stuff than if it's interesting when you're bilingual to read novels that are written in either language, and they're quite different. So it's a challenge to a degree that everyone except native English speakers have to grasp with. On the other side, I find that the native English speakers are not necessarily better at writing than people where English is a second language. So this was an interesting experience for me when I started to rewrite the grammar, among others, of what native English speakers had.
It loosely stands for checkpoint, restore, service line, and but it's, I don't like that. I don't want to call it. I just like this way.
Our tendency is to write really long, complicated sentences with commas and don't.
5 clauses.
Short sentences, one little idea in a sentence, period. Next sentence, period. Keep your sentences short. Then it doesn't matter if it stops at the end or the beginning. It's short.
Exactly.
Pull together. So that's one thing. The other thing, I read a lot. My English was very bad when I started doing this kind of stuff, and so I read a lot of books on how to write. So, this is responsibility for us. It's not just science that we're doing here. We're also imparting ideas. So it's our responsibility, all our responsibility, particularly as non-native English speakers.
99% of Americans are horrible writers. They know less grammar than you guys because you've learned English grammar. They never learned it.
One book that every person should read, including English speakers, is The Elements of Style by Strunk and White.
Yeah.
If you haven't read The Elements of Style by Strunk and White, then that's the next thing you need to read.
So I mean, it's clear that Asians have it harder than Europeans, but it's very clear that this can still be overcome. I mean, Heiber is here. Honestly, always when I review a paper of his, I always enjoy reading it because it's always really well written. And he's, of course.
I got a comment this year. Because it's for you.
But also, if you look around the top US computer science department these days and look at the early or early mid-career researchers, a very high percentage of those these days are Chinese, and they're all very good at writing papers. So YY, for example, who was the PC